Hi, in exercise P-5 we have a very interesting challenge to design the drive system for a pump so that it would feed a constrained space of a container. So then we have a mobile pumping device or unit. So here we have our pump parameters preset, and the pump is located right in the container in a separate compartment in the container, and it is separated from the rest of the system by a wall, and there is a hole in the wall for a shaft to go through this wall and connect the pump to the electric machine. So we are to design electric machine and the rest of the drivetrain. So we know how long what length of the container the pump will occupy. So we know how much space we have then for the electric machine and the rest of the drivetrain components. So here we can try to design with air-cooled components or with water-cooled components. In the latter case we should use heat exchanger. We also have an option to design the container so that the transformer would be always placed outside of the container, but then the transformer should have a certain protection class. So it is expected that you make a sketch where you show how you place the components inside the container with all dimensions in it. It shouldn't be very advanced, but understandable. Well, let's try to solve the problem with the help of DriveConstructor. So first, as usual, we set up the parameters of the pump, and then what we are after is of course the price of the components, but first of all the dimensions of the component, because we need to fit quite a constrained space. So you see the electric machine will have the diameter of 0.8 meters, that's roughly correspond to its width, and a certain length that we saw there. But we now can check what dimensions the frequency converter and that transformer have. So you see the transformer is 1000 kVA, and here you just see the dimensions. But if we now try a different machine type, permanent magnet instead of induction, you see this rated power of the transformer went down. We can see this dependency between the type of electric machine and the power rating or size and weight of the transformer. Of course, we can also try water cooling or air cooling or whatever for the electric machine and see the effect on the dimensions and cost. And as well, we can do the same changes for the frequency converter, cooling, air versus water. And then we will see the difference in dimensions for the frequency converter as well as we did for the electric machine. So here you see the dimensions, width, depth and height, and the weight, of course. And other parameters like efficiency are also important when you benchmark the drivetrain variants. So for the transformer it is a special situation because we can in principle place it outside of the container. So it can be air-cooled or water-cooled, and the protection is IP21 when it is inside, but when it is outside you have a different degree of protection. And here you see where you can find the dimensions and the weight of the transformer. Yeah, try different options. Thank you for watching.